Chapter 1: Exploring the Network. We now stand at a critical turning point in the use of technology to extend and empower our ability to communicate. The globalization of the Internet has succeeded faster than anyone could have imagined. The manner in which social, commercial, political, and personal interactions occur is rapidly changing to keep up with the evolution of this global network. In the next stage of our development, innovators will use the Internet as a starting point of their efforts, creating new products and services specifically designed to take advantage of network capabilities. As developers push the limits of what is possible, the capabilities of the interconnected network that form the Internet will play an increasing role in the success of these projects. The chapter introduces the platform of data networks upon which our social and business relationships increasingly depend. The material lays the groundwork for exploring the services, technologies, and issues encountered by network professionals as they design, build, and maintain the modern network. Upon completion of this chapter, you will be able to explain how networks affect the way we interact, learn, work, and play, describe how networks support communication, explain the concept of a converged network, describe the 4 basic requirements of reliable network, explain the use of network devices, compare the devices and topologies of a LAN to the devices and topologies of a WAN, explain the basic structure of the Internet, explain how LANs and WANs interconnect to the Internet, describe the impact of both online collaboration, video and cloud computing on a business network, explain how networking technologies are changing in the home environment, identify some basic security threats and solutions for both small and large networks, explain how this Cisco enterprise architecture works to meet the needs of the evolving network environment. Welcome to a new component of our Networking Academy curriculum, modeling activities. You will find them at the beginning and the end of each chapter. Some activities can be completed individually at home or in class, and some will require group of learning community interaction. Your instructor will be facilitating so that you can obtain the most from these introductory activities. These activities will help you enhance your understanding by providing an opportunity to visualize some of the abstract concepts that you will be learning in the course. Be creative and enjoy these activities. Here is your first modeling activity. Draw your concept of the Internet. Draw and label a map of the Internet as you interpret it now. Include your home or school, university location and its respective cabling, equipment, devices, etc. Some items you may wish to include: devices, equipment, media, link addresses or names, sources and destinations, Internet service providers. Upon completion, be sure to save your work in a hard copy format, as it will be used for future reference to the end of this chapter. If it is an electronic document, save it to a server location provided by your instructor. Be prepared to share and exploit your work in class. For example, to get you started, please visit this link. Class activity. Drive your concept of Internet instructions. This is a new thing for me. Networks are made of many different components. In this activity you will visualize how you are connected through the internet to those places, people or businesses with whom or which you are interact on a daily basis. After reflection and sketching your home's or school's topology, you can draft conclusions about the internet that you may not have thought of prior to this activity. Background scenario. Draw and label a map of the internet as you interpret it now. Include your home or school university location and its respective cabling equipment. I guess this is the same text. Yes, this is the same text. Required resources. Internet access, paper and pencils or pens if students are creating a hard copy. Reflection. After reviewing your classmates' drawings, were the computer devices that you could have included on your diagram? If so, which ones and why? After reviewing your classmates' drawings, how were some of the model designs the same or different? What modifications would you make to your drawing after reviewing the other's drawing? In what way could icon on a network drawing provide a streamlined thought process and facilitate your learning? Explain your answer. Okay guys, we will not do this anymore. Networking today. Among all, it also has sound, but I will turn it down.
Welcome.
Among all of the essentials for human existence, the need to interact with other ranks just below our need to sustain life. Communication is almost as important to us as our reliance on air, water, food and shelter. The methods that we use to communicate are constantly changing and evolving, whereas we were once limited to face-to-face interactions. Breakthroughs to technology have significantly extended the reach of our communications. From cave paintings to the printing press to radio and television, each new development has improved and enhanced our ability to connect and communicate with others. The creation and interconnection of robust data networks has had a profound effect on communication and has become the new platform on which modern communications occur. In today's world, through the use of networks, we are connected like never before. People with ideas can communicate instantly with others to make those ideas a reality. New events and discoveries are known worldwide in seconds. Individuals can even connect and play games with friends separated by oceans and countries. Do not do that, guys. Networks connect people and promote unregulated communication. Everyone can connect, share and make a difference. Imagine a world without the internet. No more Google, YouTube, instant messaging, Facebook, Wikipedia, online gaming, Netflix, iTunes and easy access to current information. No more price comparison website, avoiding lies by shopping online or quickly looking up phone numbers and map directions to various locations at the click of a finger. How different would our lives be without all of this? That was the world we lived in just 15 to 20 years ago. But over the years, data networks have slowly expanded and been repurposed to improve the quality of life for people everywhere. In the course of a day, resources that are available through the internet can help you. Post and share your photographs, home videos and experiences with friends or with the world. Access and submit school work. Communicate with friends, family and peers using email, instant messaging or internet phone calls. Watch videos, movies or television episodes on demand. Play online games with friends. Decide what to wear using online current weather conditions. Find the least congested route to your destination, displaying weather and traffic video from webcams. Check your bank balance and pay bills electronically. Innovators are figuring out ways to use the internet more every day. As developers push the limits of what is possible, the capabilities of the internet and the role the internet plays in our lives will expand broader and broader. Consider the changes that have happened since 1995. As despite in the figure, now consider what changes will happen within the next 25 years. This future holds the Internet of Everything. Fixed computing, mobility both, Internet of Things, Internet of Everything. The IoE is bringing together people, process data and things to make network connections more relevant and valuable. It is turning information into action that creates new capabilities, richer experiences and unpredicted economic opportunity for individuals, businesses and countries. What else do you think we will be able to do using the network as the platform? Unpredicted. What a shame. Advancements in networking technologies are perhaps the most significant change in the world today. Agents in the world today. Significant change agents in the world today. They are helping to create a world in which national borders, geographic distances, and physical limitations become less relevant and present ever diminishing obstacles. The Internet has changed the manner in which social, commercial, political, and personal interactions occur. The immediate nature of communications over the Internet encourages the creation of global communities. Global communities allow for social interaction that is independent of location or time zone. The creation of online communications for the exchange of ideas and information has the potential to increase productivity opportunities across the globe. Cisco refers to this as the human network. The human network centers on the impact of the Internet and network on people and businesses. How has the human network affected you? Networks and the Internet have changed everything we do, from the way we learn to the way we communicate, to how we work and even how we play, changing the way we learn. Communication, collaboration, and engagements are fundamental building blocks of education. Are fundamental building blocks of education. Institutions are continually striving to enhance this process to maximize the dimensions of knowledge. Traditional learning methods provide primarily two sources of experience from which the student can obtain information: the textbook and the instructor. These two sources are limited both in the format and the timing of the presentation. Networks have changed the way we learn. Robust and reliable networks support and enrich student learning experience. Today, deliver learning material in a wide range of formats, including interactive activities, assessments, and feedback. As shown in Figure 1, networks now support the creation of virtual classrooms, provide on-demand video, enable collaborative learning spaces, enable mobile learning. Access to high-quality instruction is no longer restricted to students living in proximity to where that instruction is being delivered. Online distance learning has removed geographic barriers and improved students' opportunity. Online e-learning courses can now be delivered over the network. These courses can contain data, voice and video available to students at any time from any place. Online discussion groups and message boards enable a student to collaborate with the instructor, with other students in the class, or even with students across the world. Blended courses can combine instructor-led classes with online courseware to provide the best of both delivery methods. Figure 2 is video about the way that the classroom has expanded. In addition to the benefits for the students, networks have improved the management and administration of course as well. Some of these online functions include students' enrollment, assessment delivery, and progress tracking. Changing the way we communicate. The globalization of the internet has ushered in new forms of communication that empower individuals to create information that can be accessed by a global audience. Some forms of communications include instant messaging, texting. IM and texting both enable instant real-time communication between two or more people. Many IM and texting applications incorporate features such as file transfer. IM applications can offer additional features such as voice and video communications. Social media consists of interactive websites where people and communities create and share user-generated content with friends, family, peers, and the world. Collaboration tools. Collaboration tools give people the opportunity to work together on shared documents without the constraints of location or time zone. Individuals connected to shared system can speak to each other across real-time interactive video. Across the network, they can share text and graphic and edit document together. With collaboration tools always available, organizations can move quickly to share information and pursue goals. The broad distribution of data networks means that people in remote locations can contribute on an equal basis with people at the heart of the large population centers. Weblogs. Weblogs are web pages that are easy to update and edit. Unlike commercial websites, which are created by professional communication experts, blogs give anyone a means to communicate their thoughts to a global audience without technical knowledge of web design. There are blogs on nearly every topic one can think of, and communicate of people often from around the popular blog authors. Wikis. Wikis are web pages that groups of people can edit and view together, whereas a blog is more of an individual, personal journal. A wiki is group creation. As such, it may be subject to more extensive review and editing. Like blogs, wikis can be created in stages and by anyone without the sponsorship of a major commercial enterprise. Wikipedia has become a comprehensive resource, an online encyclopedia of publicly contributed topics. Private organizations and individuals can build their own wikis to create collected knowledge on a particular subject. Many businesses use wikis as their internal collaboration tool. With the global internet, people of all walks of life can participate in wikis and add their own perspectives and knowledge to a shared resource. Podcasting. Podcasting is an audio-based medium that originally enabled people to record audio and convert it for use. Podcasting allows people to deliver their recordings to a wide audience. The audio file is placed on a website or blog or wiki where others can download it and play the recording on their computers, laptops and other mobile devices. Peer-to-peer file sharing. Peer-to-peer file sharing allows people to share files with each other without having to store and download them from a central server. The user joins the P2P network by simply installing the P2P software. This lets them locate and share files with others in the P2P network. The widespread digitization of media files such as music and video files has increased the interest in P2P file sharing. P2P file sharing has not been embraced by everyone. Many people are concerned about violating the laws of copyrighted materials. What other sites or tools do you use to share your thoughts? Actually, I'm using YouTube. Changing the way we work. In the business world, data networking were initially used by businesses to initially record and manage financial information, customer information, and employee payroll systems. These business networks evolved to enable the transmission of many different types of information services, including email, video messaging, and telephony. The use of networks to provide efficient and cost-effective employee training is increasing in acceptance. Online learning opportunities can decrease time-consuming and costly travel. You still ensure that all employees are adequately trained to perform their jobs in a safe and productive manner. There are many success stories illustrating innovative ways networks are being used to make us more successful in the workplace. Some of these scenarios are available on the Cisco's website. Through Cisco's website, cisco.com. Changing the way we play. The widespread adoption of the internet by the entertainment and travel industries enhances the ability to enjoy and share many forms of recreation regardless of location. It is possible to explore places interactively that previously we could only dream of visiting, as well as preview the actual destination before making a trip. Travelers can post the details and photographs from their adventures online for others to view. In addition, the internet is used for traditional forms of entertainment. We listen to recording artists, preview or view motion pictures, read entire books, and download material for future offline access. Live sporting events and concerts can be experienced as they are happening, or recorded and viewed on demand. Network enable the creation of new forms of entertainment such as online games. Players participate in any kind of online competition that game designers can imagine. We compare with friends and foes around the world. in the same manner as if they were in the same room. Even offline activities are enhanced using network collaboration services. Global communities of interest have grown rapidly. We share common experiences and hobbies well beyond our local neighborhood, city, or region. Sports fans share opinions and facts about their favorite teams. Collectors display prizes, collections, and get expert feedback about them. Online markets and auctions sites provide the opportunity to buy, sell, and trade all types of merchandise. Whatever form of reaction we enjoy in the human networks that are improving our experience. How do you play on the internet? In this lab you will complete the following objectives. Use collaboration tools. Share documents with Google Drive. Explore conferencing and web meeting. Create wiki pages. Actually I can show you a wiki of my company. Sorry, I need to check something to be sure that we can access our local wiki. Yes. Name server. Now we can do that. Well, this is our wiki. I cannot show you much, but we are saving our new knowledges and topologies and communication details in this web page. Sorry, I will not show you the topics we have in our wiki. Providing resources in a network. Networks come in all sizes. They can range from simple networks consisting of 2 computers to networks connecting millions of devices. Simple networks installed in homes enable sharing of resources such as printers, documents, pictures, and music between a few local computers. Home office networks and small office networks are often set up by individuals that work from a home or remote office and need to connect to corporate networks or other centralized resources. Additionally, many self-employed entrepreneurs use home office and small office networks to advertise and sell products, other supplies, and communicate with customers. Communication over a network is usually more efficient and less expensive than traditional forms of communication, such as regular mail or long-distance phone calls. In businesses and large organizations, networks can be used on an even broader scale to allow employees to provide consolidation, storage, and access to information on network servers. Networks also allow for rapid communication such as email, instant messaging, and collaboration among employees. In addition to internal organizational benefits, many organizations use their networks to provide products and services to customers through their connection to internet. The internet is the largest network in existence. In fact, the term internet means the network of networks. The internet is literally a collection of interconnected private and public networks, such as the ones described above. Business, small office networks, and even home networks usually provide shared connection to the internet. It is incredible how quickly the internet has become an integral part of our daily routines. should keep in mind to do this. All computers connected to a network that participate directly in network communication are classified as hosts or end devices. Hosts can send and receive messages on the network. In modern networks, end devices can act as a client, a server, or both. The software installed on the computer determines which role the computer plays. Servers are hosts that have software installed that enable them to provide information like email or web pages to other hosts on the network. Each service requires separate server software. For example, a host requires web server software in order to provide web services to the network. Clients are computers, hosts that have software installed that enable them to request and display the information obtained from the server. An example of client software is a web browser, like Internet Explorer. A computer with server software can provide services simultaneously to one or many clients. Additionally, a single computer can run multiple types of server software. In a home or small business, it may be necessary for one computer to act as a file server, a web server, and an email server. A single computer can also run multiple types of client software. There must be a client software for every service required. With multiple clients installed, a host can connect to multiple servers at the same time. For example, a user can check email and view web page while instant messaging and listening to internet radio. Client and server software usually runs on separate computers, but it is also possible for one computer to carry out both roles at the same time. In small businesses and homes, many computers function as servers and clients on the network. This type of network is called a peer-to-peer network. The simplest peer-to-peer network consists of two directly connected computers using wired or wireless connection. Multiple PCs can also be connected to create a larger peer-to-peer network, but this requires a network device, such as hub, to interconnect two computers. The main disadvantage of peer-to-peer environment is that the performance of host can be slowed down if it is acting as both a client and server at the same time. In larger businesses, due to the potential for high amounts of the network traffic, it is often necessary to have dedicated servers to support the number of service requests. The advantages of peer-to-peer networking are easy to set up, less complexity, lower cost since network devices and dedicated servers may not be required, can be used for simple tasks such as transforming files and sharing printers. The disadvantages of peer-to-peer networking. The disadvantages. No centralized administration, not as secure, not scalable. All devices may act as both clients and servers, which can slow their performance. Components of a network. Finally, the path that message take from source to destination can be as simple as single cable connecting one computer to another, or as complex as a network that literally spans the globe. This network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which our communication can occur. The network infrastructure contains three categories of network components: devices, media, services. Click each button in the figure to highlight the corresponding network component. Devices and media are the physical elements of hardware of the networks. Hardware is often visible components of the network platform such as a laptop, PC, switch, router, wireless access point, or the cabling used to connect the devices. Occasionally, some components may not be so visible. In case of wireless media, messages are transmitted through the air using invisible radio frequency or infrared waves. Network components are used to provide services and processes. These are the communication programs called software that run on the networked device. A network service provides information in response to a request. Services include many of the common network applications people use every day, like email hosting services and web hosting services. Processes provide the functionality that directs and moves the messages through the network. Processes are less obvious to us but are critical to operation of networks. The network devices that people are most familiar with are called end devices or hosts. These devices form the interface between users and the underlying communication network. Some examples of end devices are computers, workstations, laptops, file servers, web servers, network printers, VoIP phones, telepresence endpoints, security cameras, mobile handheld devices such as smartphones, tablets, PDAs, and wireless debit credit card readers and barcode scanners. A host device is either the source or destination of message transmitted over the network. As shown in the animation, in order to distinguish one host from another, each host on the network is identified by an address. When host initiates the communication, it uses the address of the destination host to specify where the message should be sent. It specified that for intermediary devices like switches, routers, and so on. Intermediary devices interconnect the end devices. These devices provide connectivity and work behind the scenes to ensure that data flows across the network. As shown in the animation, integrated devices connect the individual host to the network and can connect multiple individual networks from the internetwork. Examples of intermediary network devices are network access switches and wireless access point, internetworking, routers, security, firewalls. The management of data as it flows through the network is also a role of the intermediary devices. These devices use the destination host address in conjunction with information about network interconnections to determine the path that messages should take through the network. Processes running on the intermediary network devices perform these functions: regenerate and retransmit data signals, maintain information about that pathways exist through the network and internetwork, notify other devices of errors and communication failures, direct data along alternate pathways when there is a link failure, classify and direct messages according to quality of service priorities, permit or deny the flow of data based on security settings. Communication across a network is carried on a medium. The medium provides the channel over which the message travels from source to destination. Modern networks primarily use the three types of media to interconnect devices and to provide the pathway over the data can be transmitted. As shown in the figure, these medias are metallic wires within cables, glass or plastic fibers, fiber optic cables, wireless transmission. The signal encoding that must occur for the message to be transmitted is different for each media type. On metallic wires, the data is encoded into electrical impulses that match specific pattern. Fiber optic transmission rely on pulses of light within either infrared or visible light range. In wireless transmission, patterns of electromagnetic waves depict the various bit values. Different types of network media have different features and benefits. Not all network media has the same characteristics and appropriate for the same purpose. The criteria for choosing network media are: the distance the media can successfully carry a signal, the environment in which the media is to be installed, the amount of data and the speed at which it must be transmitted, the cost of the media and installation. When conveying complex information such as displaying all the devices and medium in large internetwork, it is helpful to use visual representations. A diagram provides an easy way to understand the way that devices in large networks are connected. Such a diagram uses symbols to represent the different devices and connections that make up a network. This type of picture of a network is known as a topology diagram. Like any other language, the language of networking uses a common set of symbols to represent the different end devices, network devices, and media as shown in the figure. The ability to recognize the logical representation of the physical networking components is critical to being able to visualize the organization and operation of network. Throughout this course and labs, you will learn both how these devices operate and how to perform basic configuration tasks on these devices. In addition to these representations, specialized terminology is used when discussing how each of these devices and media connect to each other. Important terms to remember are networking interface card, and NIC or LAN adapter provides the physical connection to the network at the PC or other host device. The media connecting the PC to the networking device plugs directly into the NIC. Physical port, a connector or outlet on a networking device where the media is connected to a host or other networking device. Interface, specialized port on internetworking device that connects to individual network. Because routers are used to interconnect networks, the ports on a router are referred to network interfaces. Actually, layer 3 devices are interpreted as interfaces, and layer 2 devices are interpreted like ports, as ports. Here we have some devices. You can see there is nothing to explain here. You can read the captions and memorize the meaning of each icon. Topology diagrams are mandatory for anyone working with a network. It provides a visual map of how the network is connected. There are two types of topology diagrams, including physical topology diagrams identify the physical locations of intermediary devices, configured ports, and cable installation. Logical topology diagrams identify devices, ports, and IP addressing schemes. Activity Part 1 Network Components Functions. Drag the network component function to its device category and divides. Provides a channel for messages and divides. No. Provides a channel for messages to travel from source to destination. Network media. Where should I? Okay. Provides an interface between the human network and the communication network. And devices provides connections for a host to the network and can connect multiple networks to form an internetwork. Check. Provides an interface between the human network and the communication network. This is end device, this guy here is an end device, this guy here is an end device, TV is an end device. What is this? Is this a server or what? Okay, let's just leave it for now. Provides a connection for a host to network, can connect multiple networks to form the. Okay, this is also an end device. Also, this one is an end device. Here is router. Here is multi-layer switch. Here is wireless router. Here is switch. What is this? Okay, I think this guy is a firewall. And provides channel for messages to travel from source to destination. Wireless signal with physical, copper media, LAN media, and serial link. Check. LAN media is this guy here. Wireless tablet is, I guess, this guy here. Printer is this guy here. Firewall appliance is this pro. Router. Wireless media is the radio wave. Multi-layer switch. Desktop computer. IP phone. WAN media. LAN switch, laptop, wireless router, telepresence endpoint. Check. You have successfully matched the network component names to the icons. Yeah! LANs and WANs. Network infrastructures can vary greatly in terms of size of the area covered, number of users connected, number and types of services available. The figure illustrates the two most common types of network infrastructures. Local area network (LAN), a network infrastructure that provides access to users and end devices in a small geographical area. Wide area network (WAN), a network infrastructure that provides access to other network over a wide geographical area. Other types of network include Metropolitan Area Network (MEN), A network infrastructure that spans a physical area larger than a LAN but smaller than a WAN. E.g., a city MENs are typically operated by a single entity such as a large organization. Wireless LAN, VLAN. Similar to a LAN but wirelessly interconnects users and endpoints in a small geographical area. Storage Area Network, SAN. A network infrastructure designed to support file servers and provide data storage, retrieval, and replication. It involves high-end servers, multiple disk arrays called blocks, and fiber channel interconnection technology. Also, I can remember another type of network called PAN, or Personal Area Network. It is like infrared ports on your cellular phones or things like that. Also, TV remote can be treated as personal area network because these two devices are communicating using network protocol. In fact, very specific network protocol. Local area networks, LANs, are network infrastructure that spans a small geographical area. Specific features of LANs include: LANs interconnect end devices in a limited area, such as a home, school, office building, or a campus. A LAN is usually administered by a single organization or individual. The administrative control that governs the security and access control policies are enforced on the network level. LANs provide high-speed bandwidth to internal end devices and intermediary devices. Wide area networks, WANs, are network infrastructure that spans a wide geographical area. WANs are typically managed by service providers or internet service providers. Specific features of WANs include: WANs interconnects LANs over wide geographical areas such as between cities, states, provinces, countries, or continents. WANs are usually administered by multiple service providers. WANs typically provide slower speed links between LANs. The Internet. Although there are benefits to using a LAN or WAN, most individuals need to communicate with a resource on another network outside of the local network within the home, campus, or organizations. This is done using the Internet. As shown in the figure, the Internet is a worldwide collection of interconnected networks, internetworks, of Internet for short, cooperating with each other to exchange information using common standards. Through telephone wires, fiber optic cables, wireless transmission, and satellite links, Internet users can exchange information in a variety of forms. The Internet is a conglomerate of networks and is not owned by any individual or group. Ensuring effective communication across these diverse infrastructures requires the application of consistent and commonly recognized technologies and standards, as well as the cooperation of many network administration agencies. There are organizations that have been developed for the purpose of helping to maintain structure and standardization of Internet protocols and processes. These organizations include the Internet Engineering Task Force, IETF, Internet Corporation for Assigned Names and Numbers, ICANN, and the Internet Architecture Board, IAB, plus many others like IEEE, ITU, and so on. ITUR. Note term Internet, which with the lowercase I is used to describe multiple networks interconnected. When referring to a global system of interconnected computer networks or the World Wide Web, the term Internet with a capital I is used. There are two other terms which are similar to the term Internet: intranet and extranet. Intranet is a term often used to refer a private connection of LANs and WANs that belongs to an organization and is designed to be accessible only by the organization members, employees, or other with authorization. Intranets are basically an internet which is usually only accessible from within organization. Organizations may publish web pages on an intranet about internal events, health and safety, politics, staff newsletters, and staff phone directories. For example, school may have intranets that include information on class schedules, online curriculums, and discussion forums. Intranets usually help eliminate paperwork and speed up workflow. The intranet may be accessible to staff working outside the organization by using secure connection to the internal network. This is called VPN, guys. An organization may use an extranet to provide secure and safe access to individuals who work for different organizations but require company data. Examples of extranets include a company providing access to outside suppliers, contractors, a hospital providing a booking system to doctors so they can make appointments for their patients, a local office of education providing budget and personnel information to the school in this district. In this lab, you will complete the following objectives. Survey your understanding of convergence. Research ISP offering converged services. Research local ISP offering converged services. Select best local ISP converged service. Research local company or public institution using convergence technologies. Okay, as I said, we will not do this anymore, so try to do this on your own. Connecting to the internet. There are many different ways to connect users and organizations to the internet. Home users, teleworkers, remote workers, and small offices typically require a connection to an internet service provider to access the internet. Connection options vary greatly between ISP and geographical location. However, popular choices include broadband cable, broadband digital subscriber line like DSL, wireless WANs, and mobile services. Organizations typically require access to other corporate sites and the internet. Fast connections are required to support business services including IP phones, video conferencing, and data center storage. Business class interconnections are usually provided by service providers. Popular business class services include Business DSL, Line, and Metro Ethernet. Oh my god. The figure illustrates common connection options for small office and home office users, which include cable, typically offered by a cable television service provider. That the internet data signal is carried on the same coaxial cable that delivers cable television. It provides a high bandwidth, always-on connection to the internet. A special cable modem separates the internet data signal from the other signals carried on the cable and provides an Ethernet connection to a host computer or LAN. DSL provides a high bandwidth, always on connected to the internet. It requires a special high-speed modem that separates the DSL signal from the telephone signal and provides an Ethernet connection to a host computer or LAN. DSL runs over a telephone line with the line split into 3 channels. One channel is used for voice telephone calls. This channel allows an individual to receive phone calls without disconnecting from the internet. A second channel is a faster download channel to receive information from the internet. The third channel is used for sending or uploading information. This channel is usually slightly slower than the download channel. The quality and speed of DSL connection depends mainly on the quality of the phone line and distance from your phone company's central office. The farther you are from the central office, the slower the connection. Cellular. Cellular internet access uses a cell phone network to connect. However you can get a cellular signal, you can get cellular internet access. Performance will be limited by the capabilities of the phone and the cell tower to which it is connected. The ability of cellular internet access is a real benefit in those areas that would otherwise have no internet connectivity at all, or for those constantly on the go. Satellite. Satellite service is a good option for homes or offices that do not have access to DSL or cable. Satellite dishes require a clear line or sight to the satellite and so might be difficult in heavily wooded areas or places with other overhead obstructions. Speeds will vary depending on the contract, though they are generally good. Equipment and installation costs can be high, although check the provider for special deals, with a moderate monthly fee thereafter. The availability for satellite internet access is a real benefit in those areas that would otherwise have no internet connectivity at all. Dial-up telephone, an inexpensive option that uses any phone line and a modem to connect to the ISP. A user calls the ISP access phone number. The allow bandwidth provided by a dial-up modem connection is usually not sufficient for large data transfer, although it is useful for mobile access while traveling. A modem dial-up connection should only be considered when higher speed connection options are not available. Many homes and small offices are more commonly being connected directly with fiber optic cables. This enables an internet service provider to provide higher bandwidth speeds and support more services such as internet, phone, and TV. The choice of connection varies depending on geographical location and service provider availability. What are your options for connecting to the internet? Corporate connection options differ from home user options. Businesses may require higher bandwidth, dedicated bandwidth, and managed device services. Connection options available differ depending on the number of services providers located nearby. The figure illustrates common connection options for organizations, which include dedicated leased line. This is a dedicated connection from the service provider to the customer premise. Leased lines are actually reverse circuits that connect geographically separated offices for private voice and or data networking. The circuits are typically rented at the monthly or yearly rate, which tends to make it expensive. In North America, common leased line circuits include T1, 1 and 54 megabits per second, and T3, 44.7 megabits per second, while in other parts of the world they are available in E1, 2 megabits per second, and E3, 34 megabits per second. Metro Ethernet. Metro Ethernet is typically available from a provider to the customer premise over a dedicated copper or fiber connection, providing bandwidth speeds of 10 megabits to 10 gigabits per second. Ethernet over copper is more economical than fiber optic Ethernet service in many cases. Quite widely available and reaches speeds up to 40 megabit per second. However, why they are writing this differently? However, Ethernet over copper is limited by distance. Fiber optic Ethernet service delivers the fastest connection available at an economical price per megabit. Unfortunately, there are still many areas where this service is unavailable. DSL. Business DSL is available in various formats. A popular choice is Symmetric Digital Subscriber Line (SDSL), which is similar to Asymmetric Digital Subscriber Line (ADSL), but provides the same upload and download speeds. ADSL is designed to deliver bandwidth at different rates downstream than upstream. Sorry, I'm so tired. For example, a customer getting internet access may have downstream rates that range from 1.5 to 9 megabits per second, where upstream bandwidth ranges are from 16 to 640 kilobits per second. ADSL transmission work at distance up to 18,000 feet. It's about 5.5 kilometers over a single copper twisted pair. Satellite service can provide connection when a wired connection is not available. Satellite dishes require a clear line of sight to the satellite. Equipment and installation cost can be high, with a moderate monthly fee thereafter. Connections tend to be slower and less reliable than its terrestrial competition, which makes it less attractive than other alternatives. The choice of connection varies depending on geographical location and service provider availability. Modern networks are constantly evolving to meet user demands. Early data networks were limited to exchanging character-based information between connected computer systems. Traditional telephone, radio, and television networks were maintained separately from data networks. In the past, every one of these services required dedicated networks with different communication channels and different technologies to carry a particular communication signal. Each service had its own set of rules and standards to ensure successful communication. Consider a school built 40 years ago. Back then, classrooms were cabled for the data network, telephone network, and video network for televisions. These separate networks were disparate, meaning that they could not communicate with each other, as shown in Figure 1. Advances in technology are enabling us to consolidate these different kinds of network onto one platform referred to as the converged network. Unlike dedicated networks, converged networks are capable of delivering voice, video streams, text, and graphics between many different types of devices over the same communication channel and network structure. As shown in Figure 2, previously separate and distinct communication forms have converged onto a common platform. This platform provides access to a wide range of alternative and new communication methods that enable people to interact directly with each other almost It took me there finally.
Instantaneously.
Instantaneously.
Instantaneously require.
Require.
Instantaneously require.
Require.
Instantaneously require.
Require. Require. Instantaneously. On a converged network, these are still many points of contact and many specialized devices such as personal computers, phones, TVs, and tablet computers, but there is one common network infrastructure. This network infrastructure uses the same set of rules, agreements, and implementation standards. Here is the first converged network we see. Converged networks. Oh my god. The convergence of the different types of communications networks onto one platform represents the first phase in building the intelligent information network. We are currently in this phase of network evolution. The next phase will be to consolidate not only the different types of messages onto a single network, but to also consolidate the applications that generate, transmit, and secure the messages onto integrated network devices. Not only will voice and video be transmitted over the same network, the devices that perform the telephone switching and video broadcasting will be the same device that route the messages through the network. The resulting communication platform will provide high-quality application functionality at a reduced cost. The pace at which the development of exciting new converged network applications is occurring can be attributed to the rapid growth and expansion of the Internet, with only about 10 million of the 1.2 trillion things currently connected globally. There is vast potential to connect the unconnected via the IoE. This expansion has created a wider audience for whatever messages, product, or service can be delivered. The underlying mechanics and processes that drive the explosive growth have resulted in the network architecture that is both capable of supporting changes and able to grow. As the supporting technology platform for living, learning, working, and playing in the human network, the network architecture of the internet must adapt to constantly changing requirements, requirements, for high quality of service and security. Instantaneously.
Instantaneously require.
Require. Instantaneously require. In this lab you will complete the following objectives. Test network connectivity using ping. We will do this right now. I am pinging to Google's public DNS server, which is reachable. It takes about 77 milliseconds to travel to the Google's open DNS public DNS server and back to my computer. It is reachable now. It uses this IP address here and so on. I'm actually using this guy to check connectivity because it also shows the path our packets are traveling to reach the destination. It shows the averages of round trip times and so on. Anyways, trace a route to remote server using Windows Trace RT. Okay, I've used the MTR utility. Sorry, I'm using Linux operating system, but you can also trace route. It will show the same path and kind of same information, but MTR is more preferred for me. Is better for me. It works better for me. MTR works better for me. MTR works better for me. Yeah. Trace a route to a remote server using web-based and software tools. Web-based tools. As far as I remember, there is ping EU or ping. Okay, ping to Google's public DNS server. It is reachable from the ping EU server. Compare trace route results. Let's trace route to Google. As you can see, it starts from the Hetzner data center and moves to Google. Okay, this is the path our packet takes from this server to reach the Google's public DNS, and this is the path from our computer. As you can see, the paths are different because we are on the different locations inside the internet. Lab mapping the internet. This sounds kind of interesting. Visual route like editions. Okay, this is interesting. We did the most part of this. You can do all these things on your own. It will be interesting. Now we will continue to reliable network. I'm sick of it. I will record the second part. I promise.